Focus on the pendulum. You are getting very sleepy. When I snap my fingers, you will think you are a chicken. The story goes that Galileo discovered that a pendulum could be used as a means of keeping time while sitting in a cathedral watching a chandelier sway back and forth. Today, we'll look at factors that determine the period of a pendulum. Today's lab is going to be determining the period of a pendulum and determining what factors affect the period of a pendulum. And this part that we've got bolted to the top hole in our stand is going to be the key part to this pendulum. It's going to give us a measurement for a base and the point to measure the length of the suspension of the pendulum. It's attached to a stand. These holes in the stand are 5 centimeters, that'd be 5/100ths of a meter apart, and on the base of the pendulum it can be adjusted. And there's simply some little knobs here that can be screwed out, and you're going to want to do that so that you can level up and actually get the stand to be perfectly plumb. The second part of our equipment is called the bob, and all the bob is a string with a weight at the end. In fact, in this particular case, we have washers so that we can adjust the weight. When the bob is attached to the plate, we're going to want to make sure that it's perfectly through. We may have to adjust our plate just a little bit because we want it to be exactly at 0 on the amplitude scale. So you may have to do a little adjusting at the beginning. The mass of the bob can be changed by removing a little stopper from the end of the string and then sliding the number of washers you want to take off. In this case, Paige is going to leave 2 washers on, take the others off, and then put your little stopper back on the end of the string. And this way, for different trials involving mass, you can change the mass of the bob. The plate is calibrated so that we can alter the amplitude, and right now we've got an amplitude of about 20 degrees. We can see that. Now if we wanted to go with a higher amplitude, let's catch that and stop that page. Now we're going to pull it out to about 30 degrees, all the way to 30, pull it 10 degrees further, and about 33 degrees there, and let it go. And now the pendulum is swinging with a greater amplitude. The length of suspension is from the pivot point up at the top peg. We'll measure from the bottom side in centimeters. Actually, we'll record it as meters, so we'll get the decimal in the right spot. And we don't go all the way to the bottom of the bob. Instead, what we want to do is go from the center of mass of the bob. So in this situation, the very bottom of the bob looks like about 0.71 meters or so, but the center of mass, because of the stack of washers, is probably about 0.68, and that's going to be an estimation based on what the number of washers are that you have on the peg and what you think the center of mass of the bob will be. The length of the suspension of the pendulum can be adjusted by taking the little stopper at the top and squeezing it and pulling through the desired amount of string to shorten the length of the suspension. It can be reattached then to the plate of the pendulum. A critical definition is what is one cycle. When the bob is released and then it returns, that's one cycle. A half a cycle would be when it got to the far distance on the other side. 1 cycle means it's returned to its starting position. To determine the period of the pendulum, we're going to need a timekeeping device. It could be a sweep second hand on a clock, it could be a digital clock that can count seconds, because we're going to want to count for a full 60 seconds. So we'll be watching that, and at the same time we'll release the bob and count.
1, 2, 3, 4, 5, 6.
And we'll continue
7,
counting for 60 seconds.
8, 9,
Then we will take
10,
60
11,
seconds and divide it by
12,
the total number of
13,
cycles in that
14,
minute, and that'll give us the
15,
period in
16.
seconds. We just ran a test run for 60 seconds, and in this particular setup we had a total of how many cycles, Paige?
40.
So we will take 60 seconds and divide that by 40, and that will give us the period of our pendulum.